Problem set number 10 in our differentiation review involves some hyperbolics. And maybe you don't remember, but hyperbolic cosine is written as e to the negative x plus e to the x over 2. And hyperbolic sine, like that, is negative e to the negative x plus e to the x over 2. And their derivatives are each other. The derivative of hyperbolic cosine is hyperbolic sine, and the derivative of hyperbolic sine is hyperbolic cosine. So it's actually even easier than our regular trig functions. So if I have something like y equals natural log of cosine hyperbolic of 3x, this gets pretty straightforward there, Rick. This derivative of the outside, then inside, then inside. This is just a chain rule encompassing everything. So derivative of natural log would be 1 over hyperbolic cosine of 3x times derivative of the inside. Well, that's hyperbolic sine of 3x. And then times the derivative of the inside again. That's times 3. So what do we end up with? We get 3. I guess it would be hyperbolic tangent of 3x. Very fast work. Very fast work. No big deal. The next one uses arc hyperbolic cosine. That one might be a little harder. Should we give it a try? If I have y equals the hyperbolic arc cosine, let's do it by itself like this. That's the same as saying x equals the hyperbolic cosine of y. And if I want to take the derivative here with respect to x, what are we going to get? 1 equals the hyperbolic sine of y dy dx. And that leads us into dy dx equals 1 over the hyperbolic sine of y. Excuse me. Felt like I was going to sneeze and almost wrote a typo. I don't know what's worse. And this almost gets us there, but we're still in terms of y. So let's remember the rules that sine hyperbolic sine squared minus, I think it's the other way around. Don't mess up your identity. Hyperbolic cosine squared minus hyperbolic sine squared equals 1. So if I want to rearrange these, put this over here and put this over here, I would get hyperbolic cosine squared minus 1 equals hyperbolic sine squared. So we can square root like that. And we can say dy dx is equal to 1 over the square root of hyperbolic cosine squared minus 1. Why would I do that? Because this, we know x is equal to hyperbolic cosine of y. So we say dy dx is equal to 1 over the square root of x squared minus 1. And I'm sorry I didn't put the y in here. I'm just moving quickly, and I assumed you understood there. So now we know the derivative here. Let's just take all of this out and hang on to that particular truth. I'll remove it like this. I love doing that. Okay, let's move this up here so we can hang on to it. And then we'll be able to do the actual problem. What's the actual problem? Y equals hyperbolic arc cosine of hyperbolic arc sine of x. So chain rule, right? It's outside and inside functions. So y prime is going to be 1 over the square root of hyperbolic arc sine of x squared minus 1 times the derivative of the inside, which would be hyperbolic cosine itself of x. So if we put it together, we would just, might even be easier, just put it on top up here like this. Let's fill this in. And we would get right here like that. And that would be our answer. That actually wasn't as hard as it looked. The trick is to be able to derive the derivative of hyperbolic arc cosine there. What's the next one? The last one looks kind of ugly. Should we give it a try? Of course, it's on our chapter review. If you can do this one, you're in pretty good shape. Let's take the challenge. Y equals cosine of e to the square root of tangent of 3x. Well, there's all kinds of chain rule happening in here, isn't there? But I think the first thing we want to look at is, of course, the outside function. What's the derivative of cosine? Well, that's going to be negative sine. And the input's the same, so that part will be easy. And now we need to take the derivative of the inside, which is this e to the whatever. And the derivative of e to the whatever is e to the whatever. So we should get e root tangent of 3x again, like that. And then derivative of the inside again, that's the exponential. How would I do that? Well, what's the derivative of square root functions? Isn't that what we want to be doing? So I think that's going to be 1/2 tangent of 3x to the negative 1/2 times, we're still going here, the derivative of the inside. What's the derivative of tangent? That's secant squared of 3x. And then one more chain rule here, times 3. So how would I put that together? I don't know if there's a great way to do it, but we can try. I think if we put this all in front, we would get negative 3/2 secant squared of 3x. Well, let's not create a fraction there yet. Negative 3 secant squared of 3x. What's going to be on top? Sine is on top. Like that. E to the square root of tangent of 3x is going to be on top. And on bottom, we're just going to get the 2 root tangent of 3x, I believe. And that's the answer. So though it may look ugly and complicated, really, the truth is it was just step by step on the chain rule. This problem set isn't very hard if you can derive your hyperbolic arc derivatives. So make sure you double check yourself on that and you'll be set for your test. This has been 10 problem sets of differentiation review.